Hey everyone! So in C#, there's this design pattern that is so fundamental, you're probably using it every single day and you don't even think about it. But here's the thing, not knowing how it really works under the hood, that can make your code fragile and a real pain to maintain. Today, we're going to pull back that curtain on the Iterator pattern. Have you ever written some code, you step back, you look at it, and you get that little pit in your stomach? That feeling that if someone just looks at it the wrong way, the whole thing is going to shatter like glass? Yeah, that feeling of brittleness is a very real thing for developers, and it's exactly the kind of hidden trap we're going to learn how to avoid today. So let's just forget about code for a minute. Think about something way simpler, your favorite music playlist. Now, behind the scenes, who knows how it's stored? It could be a simple list, maybe a super complex database, maybe even a linked list. But honestly, as the person listening to the music, do you really care how it's all put together? Of course not, right? All you care about is that you can hit next, maybe previous, and play. That simple, universal set of buttons hides all the complexity. You don't need to know the how to get the what. And you know what? This exact idea, hiding the complex guts of a collection behind a simple way to move through it, that is the very soul of the iterator pattern. Okay, back to the code. Let's look at a really common scenario and see how the most obvious, straightforward solution can secretly plant all these hidden bugs and technical debt right in your application. So here's the setup. We've got a book collection class. Internally, it just uses a good old list to hold a bunch of book objects. Now, when our main program wants to see what's in the collection, it calls a getBooks method. And that method just hands over the entire internal list. Seems harmless, right? I mean, the client can just do a standard for a loop over it. What could possibly go wrong? Well, as it turns out, this simple-looking code is actually a minefield. There are 4 huge dangers here. First, we've got tight coupling. The client code is now basically handcuffed to the fact that we're using a list. If tomorrow we decide to switch to an array to make things faster, guess what? All of our client code breaks. Second, we have totally broken encapsulation. By handing over the raw list, we've given the client the keys to the castle. They can add books, remove books, clear the whole list, completely ignoring any rules our collection might have. Third, it's incredibly inflexible. What if you want to loop through the books backwards? Well, now the client has to write a whole bunch of new logic. And finally, code duplication. Every single part of our app that needs to loop through these books is going to write the exact same for loop over and over again. It's a maintenance nightmare waiting to happen. And this is where our hero arrives on the scene. The iterator pattern is a behavioral pattern, and it's specifically designed to solve every single one of those problems we just talked about. And it does it with real elegance and simplicity. It gives us a clean, consistent way to walk through a collection. Okay, here's the textbook definition. And I really want you to focus on that last part, without exposing its underlying representation. That is the whole ballgame right there. The client gets to walk through all the items, one by one, but it has absolutely no idea, and frankly, it's none of its business, how those items are actually stored inside that collection. So, how does this magic actually work? Well, it's a team effort between 4 key pieces. First, you've got the iterator interface. Think of this as the contract. It just defines the basic rules, like you must have a move next and you must have a current property. Next up is the concrete iterator. This is the workhorse. It actually implements that interface, and its job is to keep track of our exact position as we walk through the collection. Then you've got the collection interface. Its only job is to announce to the world that it can create an iterator. And finally, you have the concrete collection, like our book collection. It puts it all together and it hands out a brand new, ready-to-go iterator anytime a client asks for one. It's just a beautiful separation of duties. All right, theory is great, but let's actually see this thing in action. We are going to apply this pattern to our flawed book collection code and just watch the transformation. You're going to see how this creates a way more robust and just cleaner system. And here it is. This is the big payoff. Just look at the client code now. No more messy for loops with index counters and checking the count. Just a simple, clean while loop. The client just asks the collection, hey, can I have an iterator? Then it just keeps asking that iterator, can you move to the next item? And if the answer is yes, we just grab the current one. That's it. It is completely 100% decoupled from the book collection's internal list. So let's just put it all together, side by side, because this slide, this is the real aha moment. Our encapsulation problem? Solved. All that looping logic is now safely tucked away inside the iterator object. The lack of abstraction? Gone. The client only knows about the standard iterator interface. That limited flexibility? Poof. We can now create a reverse book iterator or even a skip odd books iterator without ever touching a single line of client code. And the code duplication? It's completely eliminated. The logic for how to traverse the collection lives in one and only one place. Now, if you're familiar with other design patterns, you might be thinking, hey, wait a minute, isn't this kind of like the composite pattern? It's a good question, but they really solve different problems. Composite is all about treating a single object and a group of objects in the exact same way. Think like a single soldier versus a whole squad. It doesn't actually help you with how you visit each soldier in that squad. Okay, so what about the visitor pattern? This one feels a little closer, right? Since it involves going over elements in some kind of structure. But visitor is for when you need to perform really complex, different operations on those elements. It is massive overkill if all you want is simple, sequential access. Think of it like bringing a whole surgical kit when all you really needed was a key to open a door. And finally, the command pattern? Yeah, this one isn't even in the same ballpark. Command is all about wrapping up a request, an action, into an object all its own. It's amazing for things like creating undo/redo functionality or queuing up jobs, but it has absolutely nothing to do with just looping over a list of items. So you get the what and the why. But now for the most important part, the when. Let's give you a really clear checklist for when you should pull this powerful pattern out of your developer toolbox. So when should you reach for the iterator pattern? Keep an eye out for these 4 signs. First, and this is the most obvious one, you need to traverse a collection, go through its items. Second, you are serious about encapsulation and you really want to hide the collection's internal guts from the outside world. Third, you want a uniform, standard way to access different kinds of collections. Maybe you have a list, an array, and a custom tree, and you want to loop through all of them with the exact same simple while loop. And finally, this one is a really powerful use case. You need multiple independent traversals running over the same collection at the same time without them getting in each other's way. The iterator makes this incredibly easy to do. So we'll end with this question. Think back to that music playlist and its simple Next button. Now look at your own projects. Where are you exposing the messy internals of a collection? Where could you introduce a simple, elegant iterator, a Next button, to hide all that complexity, making your code more robust, more flexible, and just so much easier to maintain? That's the power the iterator pattern gives you.